A hydrogen fuel cell is a device that converts chemical energy from hydrogen fuel into electricity through an electrochemical reaction. Here's a simplified explanation of how it works. Hydrogen input, hydrogen gas H2, is fed into the fuel cell. This hydrogen can be obtained from various sources such as natural gas, methane, or electrolysis of water. Anode, negative electrode. At the anode, hydrogen molecules are split into protons, H+, and electrons, E. The electrons are then released, creating an electric current that can be harnessed to do work. Electrolyte. Between the anode and the cathode lies an electrolyte, typically a polymer membrane. This electrolyte allows protons to pass through while blocking the electrons. Cathode, positive electrode. The protons produced at the anode travel through the electrolyte to the cathode. Meanwhile, the electrons released at the anode cannot pass through the electrolyte and are forced to travel through an external circuit to reach the cathode. Electricity generation. As the electrons flow through the external circuit, they create an electric current that can power electrical devices or systems connected to the fuel cell. Catalyst. At the cathode, the protons and electrons combine with oxygen from the air, forming water, H2O, as a byproduct. This reaction is facilitated by a catalyst, typically made of materials like platinum or other precious metals, which accelerates the reaction rate without being consumed in the process. Water and heat. The only byproducts of the hydrogen fuel cell reaction are water and heat. The water produced is typically released as vapor, and the heat generated can be harnessed for various purposes such as heating the surrounding environment or being used in other industrial processes. Hydrogen fuel cells are considered environmentally friendly because they produce electricity with zero emissions of pollutants or greenhouse gases, with water being the only emission. They are being explored for various applications, including powering vehicles, providing backup power for buildings, and even for stationary power generation in remote locations. However, challenges such as hydrogen storage, infrastructure, and cost still need to be addressed for widespread adoption.